Welcome everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to recognize patterns in geometric sequences and write their corresponding sequence equations, and how to find a given term for a geometric sequence. How are we learning it? Through the Geometric Sequences Part 1 notes and the Geometric Sequences Part 1 assignment. When can we use this information? To recognize patterns in order to recognize trends in the stock market or housing rates. How do you know you learned it? By getting a score of 4 on the Geometric Sequences Part 1 assignment. Now let's take a look at our agenda for today. We will begin by going over the learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. After that, we'll go over the Geometric Sequences Part 1 notes, and then I'll give you time to complete the Geometric Sequences Part 1 assignment. Once you've completed your assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your Before You Go. Your only homework for tonight is to continue working on the Arithmetic and Geometric Sequences Study Guide and any incomplete assignments that you may have. Let's take a look at the Geometric Sequences Part 1 notes. The notes begin with the learning goals and success criteria. What is a geometric sequence? A geometric sequence is a sequence of numbers in which each term is found by multiplying the same number to the previous term. An example of this would be 2, 4, 8, 16, 32. What you should notice is every time we move from one term to the next, we have a common ratio or a multiple of 2. So we're multiplying 2 times 2 to get 4, 4 times 2 is 8, 8 times 2 is 16, and so on. How can we recognize exponential functions from a table? Well, first of all, the rule is the number of months, my x values, should be changing by a consistent amount, and it should be addition. And my y values should be changing by multiplication. So in this case, we have the months. So this is 1, 2, 3, 4. Well, is there a steady change in the number of months? Yes, there is, and it's changing by 1 month each time. Now here we have 2, 4, 8, 16. There is a steady change, and it is multiplication. We're multiplying by 2 each time. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So we're seeing a steady change, and it's multiplication. It is doubling, or multiplying by 2 each month. So therefore, is this exponential? Yes, it is. And if we were to plot these points, it would look something like this and form this curve. So we're given this pattern, 2, 4, 8, 16, and 32. And we want to know what the common ratio is. Well, we already talked about it earlier. Our common ratio is 2, and we found it by dividing this number by this number. So 4 divided by 2 is 2. So that's our common ratio. So what would the next term be? Well, we would take 32 and multiply by 2, and we get 64. So 64 would be our next term. Again, let's look at another example. What is the common ratio? We know that the common ratio is 2. Now, what would the 8th term be? Well, this is the 1, 2, 3, 4, 5 term. So we need to multiply by 2 3 more times. So this is 32 times 2 times 2 times 2. When we multiply that all out, we get 256. So our 8th term would be 256. Now let's talk about the explicit form for a geometric sequence. The explicit form looks like this. AN is equal to A1 times R to the n minus 1 power. AN in this case represents the term we are trying to find. For instance, A7 would be the 7th term in the sequence. R represents the common ratio. N represents the number of the term that we're trying to find. And A1 represents the first term in the sequence. So if we're given a pattern here, 3, 6, 12, 24, 48, we go ahead and fill this in. So AN we don't know. We do know A1, and we do know R. So AN is equal to, the first one is 3, and the R value, we're multiplying by 2 each time, so R is 2. So this becomes 3 times 2 to the n minus 1. Now let's take a look at an example. We have AN is equal to 3 times 2 to the n minus 1, and we want the 5th term. So we're going to take that, and we're going to plug 5 in for n. So this is A5 is equal to 3 times 2 to the 5 minus 1 power. Well, we know that 5 minus 1 is 4. So we have 3 times 2 to the 4th power. Well, 2 to the 4th power is 16. Then we multiply that by 3 and we get 48 is our answer. There's a video here that you can watch on how to check your work when trying to find the common ratio for a geometric sequence. So go ahead and watch that video. Let's take a look now at how we can use Symbolab to find the common ratio of a geometric sequence. So we're going to go to Symbolab.com and then we're going to find where it says Geometric Sequence Calculator. And I'm going to click here where it says Common Ratio. And it asks for the sequence. Let's say our sequence is 3 and 9 and then 27. So those are the 3 that we know. I'm going to go ahead and click Go. And it will tell me the equation right here. So it tells me exactly what the equation is. It should be a sub n is equal to 3 times 3 to the n minus 1. And it tells me exactly what my r, or my common ratio, is. My common ratio is 3. So this is how I can use Symbolab to find the common ratio of a geometric sequence. There's a video here that shows you how to check your work when trying to find a given term of a geometric sequence. So go ahead and watch that video. Let's take a look now at how we can use Symbolab to check our work when trying to find a given term of a geometric sequence. So we're going to go to Symbolab.com and then we're going to go to the Geometric Sequence Calculator. And then down here I'm going to go to the one that says Value Given Index. And we're going to enter our sequence. Now, you may have the sequence been given to you as an equation. That's okay, just fine, like the first 2 terms, that's all you really need. So let's say the first term was 4 and the second term was 18. And the term we want is the 7th term. So we just enter our sequence in here and put our index here. Index is the term we want. And we're going to go ahead and click Go. And when we scroll down, it tells us exactly what our ratio is and exactly what our term should be. So our 7th term should be 531,441 over 16. So this would be our solution. So that's how you can use Symbolab to check your work when trying to find a given term of a geometric sequence. Let's take a look now at the Geometric Sequences Part 1 assignment. The assignment begins with the learning goals and success criteria. If we scroll down, we can see the questions. It says, what type of function is similar to a geometric sequence? Well, we should recognize that we're going up by a multiple each time, so that's the same as an exponential function. So we'll go ahead and put that as our answer. The next one says, what should be the next term in the geometric sequence below? 24, 12, 6. So we can see that we're multiplying by 1/2 each time. So half of 6 is 3. So we'll go ahead and mark that as our answer. And we'll continue to answer all these questions until we get to the end. Once you get to the end of the assignment, go ahead and click Next. This will take you to your Before You Go. Go ahead and fill out your Before You Go and then submit your work on Google Classroom.